Hello, I'm going to start with what we did in class, and then I'm going to give you some information about the homework. So, starting in class, I know it has been a while. I was off, I was at a wedding, I had to give a speech. It was very scary, but it was wonderful. It's in San Francisco. And now I'm back, and we need to make sure that we are ready moving forward and doing some good thinking. So students on Thursday and Friday spent some time considering how you could build equations if you had tables that were giving you different amounts of data about quantities. And here I wanted to see what could students do if I didn't give you a table. So if I were kind of asking you to make me the data table. So here we've got the albatross. Since I was out by the ocean, I decided to think about some ocean birds. And we have an albatross, which is a large bird that can fly 400 kilometers in 8 hours at a constant speed, which is ridiculous. I mean, that's super fast. So I'm being asked, what is the constant of proportionality? And also, what does it mean? So in this context, what does that number mean? I think it's going to be helpful for me to build myself a table. So I'm going to start with hours, just because if you first have to have time pass before you can travel. So we'll do time, and that'll be in hours. And then we are talking about the distance that we can go, which is in kilometers. So I know that in 8 hours, I can go 400 kilometers. And I could consider this in two ways. I could either think directly about what could I multiply across by, or I could just try to get down to 1 hour, because the constant of proportionality is always a unit rate. Let's do that and see how we can apply kind of both elements here. So to get down from 8 hours to 1 hour, I could scale that down by dividing by 8. And if I do that here, then I also need to scale my distance down by 8, because I now have only 1/8 of the time that I had before. 400 divided by 8 would be 50 kilometers. So that tells me that in 1 hour I can travel 50 kilometers. Well, then my constant proportionality is going to be 50, because 1 times 50 gives me 50. That also works here, and it should work. 8 times 50 is going to be 400. So 50 is my constant proportionality, and I'm going to abbreviate that as COP, and it means the bird travels 50 kilometers in 1 hour. That is the meaning. Always good to think about what your numbers represent. So now I want to write an equation that involves how far, d for distance, it's going to fly in a certain amount of time, t hours. I can use labels if they are helpful to me. So I think it's going to be helpful to think about my table here. So how far d, that's going to be distance. So distance. T hours is my time. So to get from t, time, to d, distance, I know I need to multiply by 50. So if I start at t and go times 50, then I will get d, which is distance. If we kind of work backward, we can check that that works. 8 is a time, so we could say time, and we can say distance over here. 8 times 50 is 400, that is true. 1, if we go down the table, 1 times 50 is equal to 50, which we also had. So this equation holds. This is a generalization that we could use for any time that then will give us the corresponding distance. Then I had students look at some situations from last week. I wanted to see what they could do. So students did a really nice job overall presenting their ideas about proportionality. I think the place that was the most challenging for the most people was still turning it into this equation, because that's newest to us. It is more familiar to think about how you can move across the table, and turning it into the algebra is a little bit less familiar. So I'm going to run through A, B, C, and D just so that you have a kind of an overview of how that went for people today. So first, I am asking the same questions for each. Is it a proportional relationship? How do you know? If it is, what is the constant of proportionality? How do you know? And then what is an equation that you could use to represent the variables and how they are related to each other in general? So is this a proportional relationship? I want to think about ratios. If it's a proportional relationship, then they have the same ratio. So here, I'm going to do the ratio of, you could go in either direction, but I'm going to think of the ratio of C to N. So 13 to 20 can simplify to 6.5. 1950 to 3 can simplify to 6.5. 26 to 4 can simplify to 6.5. And 39 to 5 simplifies to 6.5. I have the same ratio across the board. That tells me, well, that my constant proportionality is times 6.5. If I worked my way down to one pizza, divide by 2, it's going to cost $6.50, or 6.5. So then if I have an equation, if I start with pizzas, n, and I multiply by 650, then I will get the total cost, C. Students also said that I could do C divided by 650, and that would get me n. So that would be going the other way, divide by 650. And some people said if I did C divided by n, that would also get me 650, and that's like the ratio that we have here. So multiple representations for that equation. Here, is this a proportional relationship? Let's look at ratios. 25, so I'm going to look at the ratio of W, wages, to H, hours. 25 to 2 simplifies to 1250. 3750 to 3 simplifies to 1250. And 50 to 4 simplifies to 1250. So they are all the same ratio. Yes, this is a proportional relationship. The constant proportionality is then going to be 1250. And if I multiply going across this way, that would be times 1250. The equation then, if I have any number of hours, H, over here, and I multiply by 1250, then I'm going to get the corresponding wage, W. And if we worked backwards and divided by 1250, then I would start at my wages, divide by 1250, and I could get my hours. And those are a couple different ways you could have that. You could also say wages to hours equals 1250, a third way, like we had that ratio there. Then on the back, people noticed that there was something similar about these. So, proportional relationship, 3 to 1. That ratio of y to x is going to be 3. 6 to 2, that ratio is 3. 9 to 3, 12 to 4, and 15 to 5. All 3. So that tells me, I can just multiply it down by 3. So we would have $18 and $21. So yes, it's proportional because we have the same ratio applying throughout the relationship. And the constant proportionality is 3. We've got that ratio. We see that multiplying total number of tickets by 3 gives us the total cost. So if we have X tickets, just take X times 3, we will get Y. You could also write that as 3x equals y, and something that's conventionally what you might see more. And then if you went the other way, and you do y divided by 3 equals x, you could also represent this as y times 1/3, because dividing by 3 is the same as multiplying by its reciprocal, equals x, and then that can more conventionally be written as 1/3 y equals x. So a lot of different representations. Well, it turns out that over here, this ratio is 9, let's see, y to x. 9 to 3 is 3, 12 to 4, 3. It's the same. And so all of the equations that we have here also apply in D. I'm going to tell you in the next video about where you should be looking for your practice checks. But have a good night, and good luck on your midterm tomorrow.